All right, everybody, welcome to lesson number 1 of the unit on probability. So throughout this unit, we're going to take what we kind of already know about probability and expand on the idea slightly, start to look at different things we can do with probability, and kind of go from there. So first things first, let's start with the opening exercise. So there's 2 questions in the opening exercise that are just basic probability ideas. So pause the video and try them and see how you make out. All right, so I'm hoping you paused the video and tried. So the first question says a six-sided die is rolled. Notice it says the word fair. They always use that in probability questions to make sure that you understand that there's no outcome that's more favorable than the other. All 6 outcomes are the same chance of happening. So the probability of rolling a 3. So when we show probability, we use an uppercase P, and then we put the favorable outcome inside that parenthesis. Since there's only 1 3 out of 6 possible outcomes, the probability of this happening is 1/6. Now, if you did it that way, great. If you didn't use the right notation because you don't remember from middle school, that's fine too. We're learning as we go along here. Now, probability can be shown 2 ways. It can be shown as a fraction, which is the exact probability, or it can be shown as a decimal. So if I divide 1 and 6, I would say 0.167. So this is the estimated, because it was rounded, probability. So sometimes probability is better as a fraction, sometimes it's just good enough as a decimal. Whenever we're talking about probability, we always round 3 decimal places. That's kind of a general rule of probability, and we go from there. So if we look at the next question, it says the fair coin is flipped. So coin has an option of heads or tails. What is the probability that it lands on heads? So the probability of landing on heads is 1 out of 2, or 0.500. All right, let's take a look at an example here that kind of combines these 2 things together. So it says, consider the chance experiment. Chance experiment is we're testing something, so we're going to roll the die and we're going to flip the coin, of rolling a die and flipping a fair coin. What is the sample space for this experiment? So sample space is all the possible outcomes. So I can roll a 1 and land on heads, a 2 land on heads, a 3 land on heads, a 4 with heads, a 5 and heads, and a 6 with heads. I can do a 1 with tails, a 2 with tails, a 3 with tails, a 4 with tails, a 5 with tails, or a 6 with tails. There are 12 outcomes. Now, I could have got the 12 outcomes from the get-go because rolling a die has 6 outcomes and flipping a coin has 2 outcomes. So the total number of outcomes, we can say 6 times 2, which makes 12, without creating a sample space. Like if this was a larger sample space that we didn't want to create, we could do that. This is called the counting principle. It's something you should have learned way back in 7th grade. So it says, consider the event of rolling an even and flipping a head. What is the probability of this happening? So in our sample space, we have this word and, right? And means both must happen. So the probability of rolling an even and flipping heads is however many outcomes out of 12 satisfy both of those conditions. And I'm going to circle this with a different color just so we can do the second part too. So everything I'm circling in red here is going to be an even number with heads. There are 1, 2, 3 outcomes that satisfy both of those conditions. So since there are 3 outcomes out of 12, there's our probability. Or if we divide 3 by 12, we get 0.250. This is about a 25% chance of that happening. Which is why we like the decimal sometimes. It gives us the percent chance a little bit quicker. Now, I'm using the same 2 events, an even number and rolling a head, flipping heads, But now I'm using the word or. Now the word or means either one or the other can happen for this to be an event that's truthful. So if I rolled a 4 and landed on tails, I'm satisfying the outcome here. So or means one or both happen. So the probability of rolling an even or flipping heads is still going to have 12 possible outcomes. But now I need to circle anything that has an even number or is landing on heads. So I'll do that in green. Even number, I'm sorry, heads, 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 heads. So there's 6 that land on heads. And then there are 3 options that are just even numbers with tails. So all 9 of those outcomes satisfy the condition of being even or landing on heads. So there are 9 possible outcomes that satisfy this. So we have 9 out of 12, or 0.750. So a 75% chance of that happening. So just by switching that one word, I've increased my chances 3 times, right? Which is pretty crazy. All right, another thing that happens a lot in probability are spinners. So we can theoretically look at the theory behind how a spinner is landing. So here's a spinner with 3 equal sectors. So the sectors are like these slices of pizza. It's saying that each one is equal in size, meaning that they all have the same probability or chance of happening. So what is the probability of spinning a 3? So there is 1 3 out of the 3 equal sections. Probability of not a 3. There are 2 sections that are not 3 out of the 3 possible sections. And then we have 2 probabilities that we have to think about. Probability of landing on a 4. Well, that's never going to happen, so that's a probability of 0. And the probability of spinning on an integer. All 3 of these outcomes are integers. So that's a probability of 1. Now, these 2 things have special names, right? So when something has a probability that comes out to be 1, we call that something that is absolutely going to happen. So because it's something that we know is going to happen, we call this a certain probability, right? It's going to happen. We're certain it's going to happen. A probability of 0 is something that's not going to happen. So because it can't happen, right, we call this a something that is not going to occur. So we can call this a probability that it won't happen, not definite. A lot of different ways we could describe that. All right. Number 3 says create a sample space for rolling a fair die and a spinner above. So for a fair die, we can get a 1, 2, 3, 4, 5, or 6. And then for the spinner, we can roll a 1. For the die, we can do a 1, 2, 3, 4, 5, and 6, or we could spin a 2. For the die, we can do 1, 2, 3, 4, 5, and 6, or spin a 3. So here I'm putting the die first, the spinner second, because that's what it's saying. So it says, what's the probability of rolling a perfect square on the dice and or spinning an odd? So one or the other are happening. So the probability of a perfect square or an odd number. So if I look, I'll circle everything that satisfies one or the other condition here in red. So perfect squares are 1 and 4. So in that dice column, anything that's a 1 or a 4 is going to satisfy this condition. And then on the spinner, anything that's odd, 1 is odd, and 3 is odd. Notice some of those would have satisfied both. We're just circling everything that satisfies one or the other. So out of the total number of outcomes here, which we know is 18 because we created 18 possible samples, or we could have just, or we could have just simply said that there are 6 outcomes of the dice, 3 outcomes of the spinner, so there are 18 total outcomes. So out of the total 18 outcomes, there are 14 that satisfy one or the other condition here, being a prime number on the dice or an odd number on the spinner. So if we leave it like that, that's our probability, or we can change it to our fraction, 14 divided by 18, and we get 0.778. The next one says, what's the probability of rolling a prime number and spinning a prime number? So to understand prime numbers, we have to understand what a prime number is. A prime number is anything that has multiples of 1 and itself. So numbers in this scenario that are prime numbers are 2, 3, 5. There are no other prime numbers that are in this scenario. So go ahead and see if you can find this probability on your own. All right, so the probability of rolling a prime number and spinning a prime number is 6 out of 18, or a 0.333 chance, or 33% chance of happening. There were 6 outcomes here that I circled in green that had 2 prime numbers. Those are the only 6 that work. So for the next question, it talks about a bag with cards in it. Some are blue, some are red, etc., etc. So what I want you to do is pretend we were in class. I'd say turn to your partner and try and create the sample space here for this scenario. So pause the video and see if you come up with the sample space. Okay, so taking a look at this, we have 15 different outcomes. I labeled mine colored coded to help us with the questions below. So we have our 4 blue cards, A, B, C, and D, and our 2 red cards, E and F. Each one can be attached to a spinner outcome of 1, 2, or 3. So 15 different possibilities. So the next question says, is the probability of spinning a 2 affected by the probability of pulling a blue card? So the answer to that is no. The spinner is independent from the cards. So this is starting to get us into the thinking of probabilities that are affected by each other. So there are some probabilities that are affected by each other and others that are not. For example, the probability of it raining today is not affected by the probability of whether or not I ate breakfast this morning, right? Those are independent events. Where the probability of my grass getting wet is going to be dependent upon the probability of whether or not it rains last night. So there are certain probabilities that can affect each other, right? This is one where they do not affect each other. So whatever I pull out of the bag card-wise is not going to affect how my outcome on the spinner winds up being. Okay, pretty much everything we've done in today's lesson have been independent probabilities. You'll see as the lessons progress, the probabilities will change a little bit. So it says, what is the probability of pulling a red card and a blue card? The answer to that is impossible. Since we're only pulling one card, this is an impossible, all right, improbable, however you want to explain it. So a probability of 0. What is the probability of pulling a red card or a blue card? Well, since all of our chances depend on us pulling a card and our cards are either red or blue, the probability of being red or blue, well, every single outcome is satisfied there. So this is a certain probability. So if I was to give you this scenario, I know for certain if I do this scenario, one of my cards is either red or blue. What's the probability of pulling a blue card and spinning an odd number? So here's a probability we actually have to do some calculating. So probability of blue and odd. So since there are 15 outcomes, I need to figure out how many of those outcomes are both blue and odd. So odd numbers are 1 and 3 in this scenario. So I have blue and odd, blue and odd. So the 8 things I circled there in yellow, those 8 things satisfy the condition of both being blue and odd. So there are 8 out of 15 outcomes that satisfy that condition. I could also show that as a decimal. right? All depending on how they ask the question, right? If they want it as a fraction, leave it as a fraction. If they want it as a decimal, show it as a decimal. What is the probability of pulling a blue card or spinning an odd number? So when I have the or in there, those blue cards, all of them work, right? So every single blue card works here. I'll use black here. I'm running out of colors. So every single blue card works. So all of these 12 work because of or. And then we have the red cards that have an odd spinner number. So out of the 15 outcomes, 13 of them satisfy one or the other condition. So I just noticed I made a mistake. So I'm not going to redo the video. Let's just fix this. There are 6 cards, not 5. I miscounted. So there are actually 18 outcomes, which is going to change this probability to 8 over 18. My bad. Okay, so we had 18 outcomes, 8 of them were blue and odd. Now let's go back. All right, everything that I checked there with black, that's an outcome that satisfies blue or being an odd number. So out of the 18 possible outcomes, 16 work. So the probability of being blue or odd is 16 out of 18. So if I do 16 divided by 18, I get 0.889. Sorry if that was confusing. I just miscounted. It happens to everybody. All right. So this is a good stopping point for you. So take a minute, pause the video. You could rewind the video if you were confused about something that we did in the notes before trying your homework. All right, so in the homework, it says consider the chance experiment on the sample space on the previous page, compute the following outcomes. So we're using this card. There's 18 outcomes here, so we know that there's 18 outcomes. It says picking a red card or an even number on the spinner. So the probability of red or even. So out of 18 outcomes, how many of them are red or even? So looking back here for a minute, we know there are 6 red outcomes, and then there are 1, 2, 3, 4 more that are even spinners that have blue outcomes. So in total, there are 10 outcomes that satisfy that. So 10 out of 18. If you show that as a decimal, that's going to be 0.556. Next one, probability of picking a red card and an even number. Probability of red and even. So out of our 18 outcomes, there are only 2 of them that do that. So that would be a probability of 0.111. Probability of not picking a blue card. Probability of not blue. There are 6 outcomes out of 18 that would be not blue. So if I do 6 divided by 18, that would be 0.333. Probability of picking a green card. Well, that's never going to happen, so that's impossible. So it's probability 0. All right. Number 2. The probability that it snows tomorrow is 0.62. What is the probability that it does not snow? So if there's a 62% chance of snowing, the probability of not snow would be 0.38. Now you might be asking, where did I get that number from? Well, all probabilities add up to 1, so if I subtract the 0.62, I get 0.38. The probability of picking somebody up in the United States with asthma is 20%. What is the probability of picking someone that does not have asthma? So the probability of not asthma would be 80%, right? 20% and 80% make the whole 100%. And whether you knew it or not, number 2 is actually developing an idea about probability. So it says if we know the probability of an event is P of A, what is the probability of P of not A? So P of not A is 1 minus the probability of A. This is actually an idea that you're coming up with yourself using example 2, hopefully. All right, so hopefully that video helped. We'll move on to lesson number 2 after that, and we'll keep going here with this unit. Reach out to me via email if you have problems or you're concerned about something that we're moving forward towards. Hopefully I see you soon.